friends, now I am going to teach you a new topic called as solutions. Before going to the chapter, you need to know the definition of solution. Solution is nothing but homogeneous mixture of one solute plus one solvent. It is nothing but solution. Then you need to know what is meant by solute. Solute is nothing but less component in a solution. Is nothing but solute. Solvent is nothing but more component in a solution. Is nothing but solvent. Next, we can learn types of solutions. There are three types of solutions. First one, solid solution. Second one, liquid solution. And third one, gaseous solution. We can learn one by one. First of all, what is in a solid solution? The solvent is solid. It is nothing but solid solution. The solvent is liquid. It is nothing but liquid solution. The solvent is gas. It is nothing but gas solution. Now we can study the another topic called as expressing the concentration of solution. In this expressing the concentration of solution, there are many types. First, we can learn what is meant by mass percent. Mass percent is nothing but mass of solute in gram dissolved in 100 grams of solution. A slight change in the sentence. Mass percent is nothing but mass of solute in gram dissolved in 100 grams of solution. Whereas is nothing but volume of solute in centimeter cube dissolved in 100 centimeter cube of solution. In this mass percent we are calculating mass, in this volume percent we are calculating volume, and it is measured in grams and it's measured in centimeter cubes volume percent. Whereas mass by volume percent, we have studied what is meant by mass percent and volume percent. Now we are going to study what is meant by mass by volume percent. Mass by volume percent is nothing but mass of solute in gram dissolved in 100 centimeter cube of solution. It is nothing but mass by volume percent. In this slight change is nothing but mass percent gram and volume percent 100 centimeter cube. That's it. Next, I am going to teach what is meant by mole fraction. Mole fraction is nothing but number of mole of one component to the total number of mole of all the component in a solution. See, number of mole of one component to the total number of mole of all the component in a solution is nothing but mole fraction. Next, I am going to teach molality. It's important concept. Molality is nothing but number of mole of solid dissolved in 1 kg of solvent. Is nothing but molality. Its SI unit is mole by kg, whereas molarity is nothing but number of mole of solute dissolved in 1 liter of solution. It's nothing but 1 kg. It's nothing but 1 liter. Its SI unit is mole by liter. Now I will teach you the important concept for CT. It's nothing but what we have discussed all this time related to that only. Mass percent, volume percent, mass by volume percent, mole fraction, all this concentration does not depends upon temperature, does not depends upon temperature, whereas molarity, it depends upon temperature. It depends upon temperature. As you all learnt in first PUC Dalton postulates, where it is P is proportional to nRT. P V is proportional to T. It is related to molarity, so molarity depends upon temperature. One more topic, it's very important for theory as well as CET. In theory, they have been asking for previous 5 years this topic 1 marks. I am going to tell you. Solid solutions, liquid solutions, gaseous solution. All these are solutions. It is solid, solvent, and their example. I told you what is in a solid solution. When solvent is solid, it's nothing but solid solution. When solvent is liquid, it is nothing but liquid solution. When solvent is gas, it is nothing but gaseous solution. When solid is solid, then the example is copper dissolved in gold. Example for liquid in liquid. Example for liquid in solid is nothing but amalgam of mercury with sodium. Example for gas in solid, solution of hydrogen gas in palladium. It's very important for 1 marks. They will ask what is the example for solid in solid solution, what is the example for liquid in solid solution, what is the example for gas in solid solution. Next, solid in liquid solution, the example is sugar dissolved in water. Liquid in liquid solution, the example is ethanol dissolved in water. Gas in liquid solution, the example is oxygen dissolved in water. Solid and gas example is camphor in oxygen gas. Liquid in gas is nothing but chloroform in oxygen gas. Gas in gas is nothing but mixture of nitrogen gas and oxygen gas. All these are very important for your cassette as well as 1 mark. They will ask what is meant by solid in solid solution. They will ask what is the example for solid in solid solution. Then you can tell copper dissolved in gold. Liquid in solid solution, then you can tell amalgam of mercury with sodium. Gas in solid solution, then you can tell solution of hydrogen gas in palladium. Like that only. They will ask nothing. What is meant by solid in liquid? What is meant by liquid in liquid? What is meant by gas in liquid? It's very important for your 1 mark. Then we can learn what is meant by solubility. Solubility, there are 3 types. Solubility of solid in liquid, solubility of gas in liquid, solubility of liquid in liquid. Solubility is nothing but maximum amount of solute. Maximum amount of solute that can be dissolved in given amount of solvent at a given temperature is nothing but solubility. What and all the definitions I am telling, please note down. It will be useful for your theory purpose. Solubility of gas in liquid. It is not so much important, so I will leave it. Now I am going to teach solubility of gas in liquid. Solubility of gas in liquid. Effect of pressure. In this, we can learn Henry's law. Henry's law, it is nothing but at a constant temperature, the partial pressure of each component in a solution is directly proportional to mole fraction of gas in a solution. If we take a solution, it contains number of particles. If you oppose a force, you consider it as PA proportional to XA and PB proportional to XB. PA is equal to PA naught XA and PB is equal to PB naught XB. Then we can do P total. PA plus PB. PA naught XA plus PB naught XB. It is nothing but P total. It's very important formula for your CT purpose. Keep it in your mind. Next, Henry's constant. Henry's constant or Henry's law constant. If we take mole fraction constant, then we get KH. KH is nothing but Henry's law constant. KH is nothing but Henry's law constant. KH is directly proportional to temperature and KH is inversely proportional to solubility of gas in liquid. I am writing in short form, solubility of gas in liquid. Next, when KH value increases, then it is less soluble, and KH value decreases, it is more soluble. Next, we can learn the application of Henry's law. Its application is quite simple. I will tell you in simple. It is used in a medical condition called as bends. Bends are nothing but it prevents the medical condition. Sherba drivers were provided with a tank. Sherba drivers are provided with a tank filled with helium, oxygen, nitrogen. Helium there is 11.7%, oxygen there is 32.1%, nitrogen there is 56.2%. This percentage is very important. They can ask in MCQs. Then, second application, it used to avoid anoxia. Anoxia is nothing but people at higher altitude, like mountain climbers, often fall sick and unable to think clearly. Is nothing but anoxia. I am repeating it once again. People at higher altitude, like mountain climbers, often fall sick and unable to think clearly. This type of symptoms is nothing but anoxia. When pH value increases, then temperature also increases. When pH value increases, then solubility of gas in liquid decreases. It's important. Keep this in your mind. Next, I am going to teach the difference between ideal and non-ideal. It's very important, friends. It's nothing but ideal solution definition. The solution which obeys Rolle's law is nothing but ideal solution which obeys Rolle's law is nothing but ideal solution. The solution which obeys Rolle's law is nothing but ideal solution which does not obeys Rolle's law is nothing but non-ideal solution. In this, entropy of mixing is not equal to 0. Entropy of solution is not equal to 0. Same. In this, entropy of mixing is not equal to 0. Entropy of volume is not equal to 0. Next, I will tell you the few examples of ideal gas. Few examples of ideal gas. Ideal gas, bromobenzene and chlorobenzene. Next, ethyl bromide and ethyl iodide. Next, benzene and toluene. Next, N-hexane plus N-hepsine. First of all, before going to these examples, you should know this. It is nothing but solute. Solute. It is nothing but solvent. Solute. Solvent is nothing but solute and solvent. Here also similar. Solute equal to solute and solvent. Similar. I am going to tell the example of non-ideal solution. Example of non-ideal solution. Next, I am going to tell you the examples of non-ideal. Before learning the examples of non-ideal, there are two types of non-ideal: positive deviation and negative deviation. For CET purpose, they will not ask you any definitions, nothing. I will tell you just examples. Listen. C2H5OH is nothing but ethyl alcohol, and it is nothing but chlorobenzene. Chlorohexane. Cyclohexane. C2H5OH is nothing but ethyl alcohol plus cyclohexane. Next, ethyl alcohol plus water. Next, ethyl alcohol plus carbon disulfide, found as nothing but CH2. Next, benzene plus C2H5OH is what I told. C2H5OH, ethyl alcohol. Next, CHCl3 chloroform plus carbon CCl4. Next, the example for negative deviation. Negative deviation, NHO3 plus H2O, NHO3 plus NHO3 is nothing nitric acid plus CCl3. CHCl3 is nothing chloroform. CHCl3 plus diacetyl. Next, chloroform plus acetone. Next, acetone plus aniline. All these are the examples for negative deviation, and this is the example for positive deviation. This is the overall view for ideal and non-ideal. It's very important. Ideal means it obeys Rolle's law, it does not obey Rolle's law. This is only the important point for theory purpose. If for CT purpose, they will ask you the definitions, I mean examples. What is the example for ideal, non-ideal? Keep it in your mind. You can make the overall view. What and all I made from this many times. This is the overall view. If you want, you can take it screenshot. It's bite simple. If you learn all these concepts, then you can easily understand this lesson. If you like this video, please like, share and subscribe. Thank you friends.